It's been a minute since my last update on my animated short film, so I wanted to share some of the progress I've made, which will include the topic in the title of this video. Along the way, I'm going to show you some of the changes I've made to the normal pipeline to solve various issues, as well as how I brought together some of the techniques from my prior videos to prep this short for production. With the crazy amount of work I have slated for this short, one of the key elements I needed was to develop a Maya-centric character effects pipeline for home. I needed to script a tool that would open a sequence of Maya files one at a time, driving what's inside via shape, attributes, or constraints using various caches and then outputting the results. Here's the finished scripts you want. This gives you options of what to simulate, like shot, character variation, sim type, and which number of the sequence to start and end on. This is built to allow generic character rig files to be reused across a majority of shots, and if required, override files can be placed in the shot context to be used instead. The scene setup script optionally sources mel scripts based upon the shot or character variation, as well as has the ability to import and set up collision objects. The default output option is Olympic caches with optional screenshot after each frame for diagnosis and status updates. Another output type is texture baking, which I'll explain further in a moment. Here's an update on Ivan's character effects muscle rig. This older and too active body simulation with temp shaders was used for testing purposes. I wanted Ivan to appear lean with zero body fat, visible muscle and bone structure, hence designing the muscle and bone as his final body shape. The rig includes standards like muscle and skin sliding fascia paths, but also features less use setups like dynamic sliding and pumping veins, optional loose simulated jawbone, muscle fibers that accentuate as the muscle flexes, and both simulated facial and hand tissue, which you can see more information about in other videos on the channel. Here's a render with simulated animation that's closer to what the final will look like. One of the things I want to highlight is these distinct crease lines transferred from the muscles, creating planes in the body. This is extremely difficult to do in combination with skin slide. When poly detail slides as the body distorts, these creases break. The typical solution subdivides the fascia paths to be incredibly dense. This works, it's not a good solution, but it works. The second issue I wanted to solve was the decoupling of sim geodensity from the density of the cast geo you deliver to lighting. For example, I have a knuckle wrinkle sim that needs quite extreme subdivisions to get the look I want. This is perfectly fine for those tiny patches of skin, but if I subdivide the entire body mesh to match, it's going to create extremely dense meshes which would take up an enormous amount of disk space. My solution to both these issues loops us back to the reason I implemented the baking of a stream of textures. To bake the displacement difference of the fascia to a modified version of the simulated muscle where I've added details like fiber striations based upon flex state. This technique gives me the look of very thin skin and lets me retain those distinct crease lines as the skin slides, while still staying extremely light all the way up to the time of render. Now the lighter can choose how dense the character needs to be based upon the shot cam and possible obstructions. And when the divisions aren't needed, Arnold's auto bump function still lets you see the sim. To finalize the character effects delivery, this technique requires a simple comp. Moving into Nuke, I created this gizmo for the character because the comp is very generic from shot to shot and doesn't need much tweaking. Once you choose its shot name and character variation, it just needs to be rendered. The modular part of all of this is if you choose to skip the knuckle wrinkle sim and the images aren't in the appropriate directory, then the comp automatically switches over to a generic still image instead. There are other really nice things about moving over to animated displacements, like how I'm implementing my subtle vein pumping effect as a comp modification. One other thing I'll highlight is I created a better camera pipeline from animation all the way through lighting. I wanted to leverage the character effects simulation setup to add optional natural handheld motion data driven by the same motion that's driving the character simulation. I also needed a tool to build a camera rig within the lighting file, with controls allowing the lighter to make modifications and choose the amount of handheld motion. We'll see another example of this in my next render. Everything you see here is driven by simulation, even the background. The only thing that was hand animated was the run-up to seat the characters in place. This render test showcases characters running through a more modular pipeline, which minimized the time from dynamic animation to renderable characters by skipping features like full body muscle simulation. The best part of this pipeline is the flexibility to layer on additional features after this point, such as isolated neck muscles, hand simulations, or face simulations depending on the shot's requirements. This update provides a glimpse into some of the more interesting aspects of creating this film. I hope it gives you some useful ideas. Thanks for watching!